Okay, I'm going to show you a few ways that you can compute certain diversity metrics in Excel, but I don't recommend it because Excel can become really cumbersome to do this, especially with large data sets. So I'll show you a few computations so that if you want to check your work in R, you can do that, but getting used to using R for, and the vegan package is really what you're going to want to do. But say I have a data set. Here's an example data set of birds in an exotic tree plantation, actually a recently planted 2-year-old exotic tree plantation in Borneo. And this is survey data from there. And each row represents a point count plot. And then each column is a species. So you can scroll across and actually see this matrix of data. So you can compute some basic metrics of that community using some functions in Excel. One very obvious one is you can look at the abundances of species in the community. The abundances of the individuals. This doesn't tell you the species, but individual abundances of birds by just using the sum function. So you can enter the sum function equals sum, and then you select the range of data that you want to do that for. I have left species that I did not observe in the matrix blank rather than entering 0. Sometimes that makes things more simple. And I can enter that function and you get your abundances of individuals that way. And so I can actually drag that equation down and have that as some information. Another thing you can do is calculate species richness. Richness is a very commonly reported metric. It doesn't take into account the relative abundances of individuals if you're counting abundances, but it can give you an idea of diversity in a system. And you can use the count function if you want to do that. And you do that by entering equals count and then your range of data. And again, I'll select the same range of data that I did for my summary, for my summation function. And so now what I have is, and what this count function has done is counted the non-blank cells in my data set. If your matrix has zeros in it, you can use a similar function called countif, and you select your range of data, and then you add a comma, and then in parentheses, the double quotes, you can enter a function. In that case, you would say greater than 0. Okay? But it actually is a little simpler. It's a little simpler if you leave these cells blank for some of these calculations. So I can drag that equation as well. So we've calculated total abundances in each plot. You can get averages and make these comparisons of among different habitats. You can compare richness. That's pretty straightforward with Excel. It's when you start to get to the place where you're making species accumulation curves because they look much nicer and they provide a lot more information if you reshuffle your data. Excel can do that, but it doesn't do it without add-ons that cost some money, and it still requires a bit of data manipulation. So we're not going to cover that. And then there are diversity indices that you can calculate using Excel. And they can also be quite cumbersome to calculate if you have a large data set. I'm going to show you how to calculate Shannon's index so you can get an understanding of how that could work in Excel. And I do that by actually copying my data, including the abundances, over here. And I copy the values, okay? And so when I go into my cell, and if I go over here and look at this cell that's showing me the abundances, but I actually click in the cell, what Excel is looking at is a formula. When I just paste the values, Excel just looks at that as a number. And that's useful when you're making computations in Excel to be using. if you're going to include a number in a computation, it needs to just be the number and not the result of a formula. Otherwise, things can get kind of messed up. And so I can actually enter the formula for Shannon's index into Excel. And the formula is for each individual in a sample, you're going to take its proportional abundance and multiply it by the natural log of its proportional abundance. So you get a value from that, and then you add up each value in that sample to get your total. And so I can enter that equation into Excel for each species. And I'm going to start that off by typing in equals. And then I'm going to actually select the first cell in this data set, because it's my original survey, divide that by the abundance calculation. And again, just that number, the output of that abundance calculation. So that, if I type that in, and I'm going to put it in parentheses because I'll need those parentheses later. If I type that in, I get a 0 because there's a 0 value in here. But if you scroll that over, let's scroll this formula. Oh, actually, I need to make sure that I'm going to put a $sign in front of the column reference for this, because if I scroll across, what that $sign tells me is to keep the column in the same place. So if I scroll across, I will still be referencing column CU. If I don't put that in there, okay, and I scroll my formula across just by 1, oops, scroll that formula across. If you actually look at the formula, it has shifted. There's cell referencing here that has shifted to the wrong column to be dividing my data by. It's dividing it by this empty cell now, CV2. And so I go back to this formula, I enter my $sign, and it holds the column CU in the same position. So I can scroll across. And now again, my calculation, it's now referencing cell B2, which is the correct, oops, it should be referencing cell C2, make sure I'm doing that. Referencing cell C2 and the correct column. Once I'm sure about the cell referencing, I can then drag that formula across the entire first sample of data. And what I now have is a calculation for the proportional abundance of these species in the sample. And so the next thing that I'm going to want to do is multiply that value by the same exact formula. By the log natural of that same exact formula. Okay, so I just copied that formula. I typed in LN, which gives you the log natural of the associated values. And I've done that. And actually the output here, if I open this up, is going to give me say, oh, that makes no sense, because you actually can't take a natural log of 0. I'm not going to worry about that right this moment. I'm going to scroll across again. Okay. And so for the cells where I actually had counts, I'm actually getting a number. But the cells where I have 0 values or no value, I'm getting this error sign that says number. Okay. And what that means is there's a number error. It couldn't perform that function. And we'll deal with that later. Okay. So now that I have this value, I can actually, and I'm sure that it's correct, I can actually drag that value, that same formula, to all of my cells. Okay, and I double check to make sure that it is the cell referencing is working going down. So I should still be referencing column CU, but now it should be CU3 on this row. Yes, and it's doing it correctly. And so for a lot of these, a lot of my counts are 1. So I'm going to end up with this 0 value for a lot of them. But for some of my counts, I had greater than one individual. And now what I have in each cell is that computation of the proportional abundance of the species in the sample, each species, times the log natural of that calculation. And at this point, what I can do is I can perform a sum function. I actually can't, but I'll show you how I would do that. I could actually perform the sum function and select my range of data to sum, to add everything together, and it's going to give me an error value. Okay, and so what I need to do here is actually paste, I forgot, I have to paste this again, these values again, as numbers. And so this is again why learning a few lines of R code makes things a lot simpler. So I'm going to copy this data set and I'm going to paste it just as values. And it's still not going to be able to perform this sum function because it can't add up error values. Okay, and so I'm still getting this error value here because it's not recognizing these cells with the errors as something that's a number. And so what I need to do at this point is do a find and replace. Okay, and so I'm going to select this range of data. I'm going to click find, and I'm going to click in this error code, which is hashtag capital NUM exclamation point. And then I'm going to hit replace, and I'm just going to leave it blank. And so what that's telling Excel to do is to, for every time it finds, in the range of data I've selected, every time it finds that, to just replace it with blank. And there we go. It made a whole bunch of replacements. And now I can actually use that function here, the sum function, to calculate the inverse of my Shannon's index. So Shannon's index, when you actually look at the formula, it's the negative summation of these values. And so the reason it does that is it's more intuitive to be looking at that number as a positive value rather than a negative value, because the larger that number is, the more diverse your community is. And when it looks negative, it means it's harder to interpret. And so the final step would be to, let's see if it will just do it that way. Yeah, just to put a minus sign in front of that, and you'll get the correct Shannon's values here. Okay, so I can do that for my whole range of data, and I can get the Shannon's index for each sample. And so that's how you do it in Excel. There are other formulas you could compute in Excel that we are doing in R, like the Chow's estimator. You would first need to find the species that are only occurring in 1 or 2 samples. You would look for that manually, and then you would plug those in to the calculation for the Chow's estimator. To plot a species accumulation curve, you really can't do it that effectively. But you can at least check some of the work you're doing in R. If you're not as familiar with R, you can look at it with using some basic formulas in Excel if you're more comfortable with Excel.